Okay, so for today we'll just have a look at the exercise test that I gave you. This is the first page of 5 pages. If you don't have these pages, just quickly copy and paste or write it over however you want, or you can just work it out on the screen with me. So the first question they ask you is study the following pattern. Okay, so there we see at term 1 there's 7 tiles. Term 2 there's 7 tiles and then 5 was added. And at term 3 there was 7 and then the 5 that was added and then another 5 that's added. So every time there's 5 tiles that are added to each term, meaning it increases by 5 each time. Okay. Now they say 1.1, complete the following table. There you have the pattern numbers 1, 2, 3, 4, 5, and then look carefully. They skip 6 and go right to 7. So you need to have a look at these numbers carefully, otherwise you'll make mistakes if you assume that that is 6 and in the meanwhile it's 7. Okay, so the number of tiles at pattern 1 is 5. So then you would just say 5. Oh, sorry, it's not 5. It's 7. Okay, pattern 2, it was 7 plus the 5, which gives you 12. At term 3, it's again just add 5 to the 12, that gives you 17. And then again just add 5, that gives you 22, sorry. And at pattern 5, just add 5 again, so that gives you 27. And then you'll see they skip 6. Now pattern 6 would have been 32 if you added 5 to 27. And add 5 again to 32. And that's 37. So that would be pattern 7. Okay, so just make a note here. The 6th pattern would have been 32. Okay, so you just add 5 to that to get your 7th pattern, which is 37. Okay, and now you're done with 1.1. 1.2, write down the rule that describes the relationship between the tiles and pattern numbers. Now when we write down the rule, we write it down as term n, so it's the nth term, equals what? Meaning we need to get a way of figuring out what the nth term would be. Now the nth term is any term. Okay, so I could ask you for term 5 or term 50 or term 100. So if I give you any number or any term, you need to be able to figure out how many tiles there will be at that term number. Okay, so this is quite easy if you know this trick that I usually use. I take the number that we add or subtract each time, and I multiply it with the first with 1, the first term. Let me just get another color pen quickly. Okay, so I'm going to use red. So I'm going to multiply with the first term. So I'm going to say 5, that's how many we add each time, times 1 gives you obviously 5. Now how do I go from 5 to 7? Because that is the number of tiles that I have at the first term. What do I add or subtract to go from 5 to 7? You add 2, right? Because 5 plus 2 will give you 7. Okay, and that's basically what you did here. What you did here, you multiplied it with 5, and then you added 2. That is your rule. That is the rule that you will use each time to get each term's number of tiles. So you're going to multiply with 5 and then you're going to add 2. You can go test it, obviously. If I say, let's say I want to test the third term. Okay, so we know at the third term we had 17 tiles. Okay, so let's see if I multiply 3 with 5 and then add 2, will I get 17? So I'm going to say 3 times 5 plus 2. Okay, so 3 times 5 is 15. And if I add 2, that gives me 17. So yes, it works out. Okay, so if you want to write this down, you would say term n, or the nth term, equals 5 times n. So you multiply the term number with 5. The term numbers are this 1, 2, 3. And then you add 2. And that's your rule. Every time, now you can go work out 1.2. They ask you how many tiles will be in the 12th pattern. So you're going to use this rule to work out how many will be in the 12th pattern. All you do is you take your formula, and wherever there's n, you will substitute it with 12. And remember, we substitute in brackets. Okay, always. All substitutions needs to be in brackets. Obviously, you will have to do this step underneath here. Okay, I do not have that space. I can, however, do it at the side here. Let's quickly do that, just to do it properly. Okay. Oh, close that bracket. So 5 times 12, you can use your calculator for this. That would be 60 plus 2, which means that in the 12th term, the number of tiles that there will be is 62. Okay, so at number 1.4, they gave us 55 tiles. It should have been 57 tiles. So that was just a small mistake. So they ask which pattern will have 57 tiles. Okay. So that's okay. So now instead of working out how many tiles that pattern number will have, you are going to just do the opposite. Okay, so first thing we need to do is we need to write down the formula. So our formula or our rule is nth term 5 times n plus 2. Okay, so we know how many tiles there will be. So just substitute Tn with 57. Okay, we don't know the term number. We're going to work out the term number. Now the term number is n. So we need to work out what n is. And if we want to do that, we need to get n alone. How do we do that? We take over everything except for n. Until n is alone, when we do have n alone, then you will have your answer. So first thing we can take over is the plus 2. If we take over plus 2, it becomes a minus 2. So here it was a plus 2. Now it will become minus 2. 5n still remains on the right hand side. 57 minus 2 is 55. Okay. How do I get n alone here? Remember, 5n means 5 times n. If I multiply on this side, and I take it over, I'm going to divide on the other side. So it's going to become 55 divided by 5. Okay, 55 divided by 5 is 11. So that means that in the term is the 11th term. So at the 11th term, you will have 57 tiles. Okay, if there was another table here added for the 11th term. Okay. At number 2, they give you x and y. If x is minus 1, then y is 4. If x is 0, then y is 2. If x is 1, then y is 0. And if x is 2, y is minus 2. We are going to have to figure out if x is 10, what will y be? And we'll also have to figure out if y is 60, what will x be? So that's A and B we'll have to figure out later on. Let's just get to number 2.1. Determine the rule of the table below. Determine the rule of the table above. So this table. So the same way we did it here, we're going to have to figure out what the rule is. Okay, let me just make some space here for us. Okay, so let's have a look. What do I do first to get from minus 1 to 4 and from 0 to 2? Okay. Okay, so let's have a look at the first 4 terms. We'll see a pattern forming just by looking at these 4. Okay, so have a look. This is in order. Minus 1, 0, 1, 2. So that's in order. So at the first term, basically, let's say that's the term. The pattern is 4. At the next one, it's 2. And at the next one, it's 0. Oh, that 2 is terrible. Let's just quickly, let me just fix that. 2. And at the next one, it's minus 2. So have a look, what happens each time in this pattern? From 4 to 2 to 0 to minus 2. So every time you subtract 2 in the pattern. Okay? So remember what I said? You take this, whatever you plus or minus, and you multiply that with the term number. Let's take this first one. Always take the first one. I'm going to multiply minus 2 with minus 1. Okay, multiplying that gives me a positive 2. Remember, a minus and a minus makes a positive. So what do I have to do? What do I have to add or subtract to go from 2 to 4? I need to add 2, and that will give me 4. So basically this, what we did here, firstly we multiplied, we multiplied with minus 2, negative 2, and then we added 2. Okay, remember whatever we do to the term number, that's our rule. So I multiplied minus 2 to the term number, and then I added 2 to give me my answer. Let's have a look. Let's just test the second, the term 2. Let's just test this one. If I say 2, remember I need to multiply negative 2 and then add 2. I'm going to say 2, multiply negative 2, and then add 2. Okay, so firstly we do the multiplication. 2 times minus 2 or negative 2 is negative 4. Okay, and then I add 2. Remember, if I add 2 a negative, it will become minus 2. If you get confused about this, If you think it should be -6, you are incorrect. Just go have a look at a number line. There's my -4, -3, -2, -1, 0. So if I add, I move right. Okay, so I'm going to move right 2 times. 1, 2. Okay, so that gives me -2. If I have to subtract, it will go into the negatives even more. Just think of it like this. I owe someone 4 rand. I pay them back 2 rand. How much do I still owe them? I still owe them 2 rand. Okay, so that's another way of thinking about it. So I took the term 2, okay, and I got my y as -2. So is that the correct rule? Yes, it is. So what do I do? How do I get y? I say -2 times x. That's what I did. I multiplied the x's with -2 and then I added 2. Now that's my rule. Quickly take note. When I work with terms like this, pattern numbers, I use Tn, nth term. But when I have x and y, if I want to get y, I need to use y here. How do I get y? And what do I do to x? So I need to use x there. Okay, so that's my rule for this pattern. Y equals -2, x plus square. Plus 2. Okay, the next one, 2.2, calculate the value of a and b. So now I can use my rule to calculate our a and b. So with a, just going to make some space here. Okay. Okay, so first things first, you write down your rule. So it's y equals 2. Y equals -2x plus 2. Okay, so I want to get a, and a is in the y place. Okay, so everything just stays, I'm going to get a. Okay, so I substitute y with a. To get that, I need to say -2 times x. Now what is x here? Okay, it's 10. So I substitute x with 10. Remember, substitute in brackets. And then I just work it out. -2 times 10 is negative 20. Plus 2. Now remember, I owe someone 20 rand. I pay them back 2 rand. How much do I still owe them? 18 rand. It's not a -22, it's -18. Okay. So if x is 10, then y will be -18. Okay. Next, we need to figure out what b is. So again, first things first, write down your rule. Okay, so in this case, we know what y is. Y is 60. So you substitute y with 60. We don't, however, know what x is. So x stays x. That's the one that we need to figure out. Now, if you want to figure it out, we need to get it alone. So if we want to figure out what x is, we're going to take over the rest of the numbers or the digits until x is alone. So first thing I can take over is the +2. If it's a +2 or +2 here, and you take it over, it becomes a minus 2. So it's going to be 60 minus 2. And then minus 2x remains on this side. 60 minus 2 is 58. Okay, now I need to figure out how to get x alone. So remember, if they are right next to each other, it means multiplication. So in this case, it's minus 2 or negative 2 multiply x. If I take it over, it becomes a divide. Okay, multiplication becomes division. It's only the multiplication that becomes a division. In this case, the number stays minus 2. It stays negative 2. You can only change the action. You cannot change the number. So if the action is multiplication, then that's the one that you can change. It becomes division. But you cannot change the number itself. If it's a negative 2 here, it stays a negative 2 on the other side. Okay, 58 divided by negative 2. Remember, a positive and a negative makes a negative. 58 divided by 2 is 29, negative 29. And that's my x. So if y is 60, then x will be negative 29. Okay, so that's page 1. Let's move on to page 2. Okay, here I have page 2 and 3. So 2.3 is still part of the previous answer, or the previous question at least. They say complete the table. Okay, so it's basically the same as what we did with the x and a y table. Here they actually give you how to work out the nth term. So you don't have to figure that out by yourself. You just need to substitute n in this equation. Okay, so here they give you n. If n is minus 1, what will the nth term be? So all you need to do is just write down the formula or the rule. So it's minus 2 to the power of n plus 3. So now you're just going to substitute n with minus 1. Okay. So minus 1 to the power, minus 2 to the power of minus 1. So first thing you need to remember is that to make this exponent a positive exponent, you need to switch it on its fraction. So minus 2 to the power of 1 on a fraction is minus 2 to the power of 1 over 1. Okay? So every number can be written over 1. So for me to switch these two, so if I switch these two, if I say 1 goes on the top and minus 2 to the power of minus 1 goes at the bottom, my exponent will go from negative to positive. It's going to be 1 over minus 2 to the power of 1. Okay. Okay, so now you don't even actually have to write down the 1 there, because if I say 3, I automatically know that there's a to the power of 1. Okay, so you don't even have to write it there. You can just say it's now 1 over minus 2, just to make it less complicated for you. And then I'm going to say plus 3 over 1. Remember, if I add or subtract with fractions, everything needs to be over a fraction, and they need to be over the same denominator. So I'm going to make these denominators the same. So if I want to make them both negative 2, because they both can be negative. They both can be negative 2. So if I want to do that, then I would multiply this one with negative 2. I would multiply it with negative 2. So 1 times negative 2 becomes negative 2. And remember what I do at the bottom, I need to do at the top. 3 times negative 2 is negative 6. This one stays the same. Okay, and remember again, if I add or subtract, my denominator stays the same. It's only the numerator that will then increase or decrease. So 1 plus minus 6. Now remember, a plus and a minus like this next to each other needs to be married. And when they become married, they become 1. And what does a positive and a negative make? A negative. So it's going to be 1 minus 6. That gives me negative 5. And that's your answer. Okay, so negative 5 over negative 2. I can simplify this by saying that a negative and a negative makes a positive. So it's going to be 5 over 2 then. Okay. Or you can just say these two cancel each other out. And I can't simplify it more than that. In some cases you can, but in this case it's 5 over 2. Then your answer will be 5 over 2. Sorry, my space isn't a lot there, so it's kind of squished in. Okay, and that you do with the rest of them. So if n was 0, sorry about that. If n was 0, that's quite easy. Remember, anything to the power of 0 is 1. Anything, absolutely anything. If I have a trillion and to the power of 0, it will be 1. If you have negative 200 to the power of 0, it will be 1. Anything to the power of 0 is always 1. Okay, this is quite easy. So if n is 0, then the nth term will be 4. Okay, let's skip this one for now. Let's just go to the last one. If n was 7, then what will the nth term be? Now remember, it's tricky with these. If I have a negative 2 to the power of 7, it's not going to necessarily be a negative number. You need to keep in mind that you multiply negative 2 7 times. Okay? And remember, a negative and a negative makes a plus. I'm going to show you now. 3, 4, 5. Oh, the space is so limited. Just squish it in here. Okay? Okay, so negative and a negative makes a positive. And a 2 and a 2, 2 times and 2 times 2 is 4. Okay, so now I need to keep in mind a positive and a negative will then make a negative again. And 4 times 2 is 8. So again, I'm going to say negative and a negative makes a positive. 8 times 2 is 16. And now again, a positive and a negative makes a negative. 16 times 2 is 32. Minus and a minus makes a plus. 32 times 2 is 64. And then a positive and a negative makes a negative. 64 times 2 is 128. Okay, so it's, your final answer is minus or negative 128. And that's also plus 3 then. And remember, if I owe someone 128 Rand, I pay them back 3 Rand. My debt will be less, but I will still owe them 125 Rand. Okay, and that's your answer here. 125. Oh, sorry, negative 125. Okay, so now that we've done that, let's go to this to the next one. We need to go figure out what the term number is, n. We need to go figure out what n is. Okay, so I realized there was a mistake. For this to work, we need to make this negative 5. Okay, so for this specific calculations to work out. So sorry about that. Just fix it on your paper if it's not fixed already. So we have the nth term here. We want to figure out what's the term number. So again, just write down the formula. That's always the first place you can start. Just by writing down the formula and then substitute from there on. So we don't know what n is, but we know what the nth term is. That is negative 5. Okay, and the rest you just write down as is. Gonna figure it out now. Okay, so first things first, for me to get n alone, I need to take everything else over. So first thing I'm going to take over is the plus 3. It becomes minus 3 on this side. So it's negative 5 minus 3. And then this stays the same. So minus 5 minus 3 gives you minus 8. Okay. So now, the first thing we think we have to do is to take n over and it becomes a root, right? But we don't know what n is, so we wouldn't know what root to put over here. So what we then do is make our ground numbers the same by changing the exponents. So I need to change this exponentially so that minus 8 will be the same as minus 2. Now if I say change this exponentially, you need to change it in the exponents. That's what I mean when I say that. For me to get from minus 8 to minus 2 is I need to go figure out what is the what type of root. Is it a cube root? Is it a square root? Is it a what type of root do I need to use to get minus 8 to minus 2? Okay, now it's not a square root because a square root cannot be a negative. Okay, because there's in no case or no scenario will a negative and a negative make a negative. But I can say it's a cube root. Okay, because a negative and a negative and a negative will make a negative again. And the cube root of 8 or minus 8, and you can figure this out on your computer, your calculator. It's much easier. And if you do, you'll see that the cube root of 8 is of minus 8 is 2. So that means the exponent of minus 2 needs to be 3. Okay, so now I have my ground numbers the same, and if I do, I can just, I'm not going to throw them away or cancel them out. It's just that in this case, my unknown my unknown is at the exponents. Okay, so not at the ground. It's there at the top. So for now, I'm just going to take that away and just work with the exponents, because that's where I need to figure out what my unknown is. Okay? And if you do that, you'll see that n is 3. Okay? So n equals, that means n equals 3. Okay, we've done this this concept before. If you have forgotten it, just go back in your book to where we've done this and go do it again so that you know this. I don't have the time to explain this to you now. So just go back or go watch other videos on how to make ground numbers the same and so forth. So you can just go and have a look in your book. It is there. We've done it before. Okay. So now my table is complete. So I've completed that 2.3 answer. In term 3, the number will be -5. So that's how we figured that out. Okay. So to the next question, 3.1, determine the equation for the following graph representation. Okay, so we need to go work out what the equation is. Okay. So by first glance, we see that this is a linear graph. Okay, and this you need to know. The equation for a linear graph is y equals mx plus c. Okay, that you need to go study. The equation for a linear graph is y equals mx plus c. Okay, so in this equation or this graph, we know what y is. We can figure it out from this graph, and we'll know what x is. Okay, remember this is my x-axis, that's my y. Okay, but that they give us by using this line. We don't know what m is. Now m is the gradient. Okay, don't know what the gradient is? Again, go have a look in your book. So we need to figure out what the gradient is. Okay, how do we do that? We say vertical change over horizontal change. So how do we figure out what the vertical and horizontal change is? That's easy. You start at a corner, let's say there, and go down until we see another corner meet. Now there's no corner that meets over there. These lines don't meet over the corner, but there, here the line again meets over the corner. So it's drawn over so it's basically from one corner until the other corner. Okay, you can mark it with dots like that. So from there to there, the vertical change, so it's going down, is 2. 2 down. That's my vertical change. Okay. The horizontal change is 3 right. So 1, 2, 3 right. Okay. So we know that going down is a negative. Okay. So if you go down, it's negative. If you go up, it's positive. If you go left, it's negative again. You're moving into the negatives when you go left. And if you go right, you're moving into the positives. So here we say 2 down is 2 negative, and going 3 right would be a positive 3. Okay, so this is my gradient. I can't simplify it more, so you just take this whole fraction as your gradient. Okay. Okay. So let's say y over here is obviously 2. My gradient is -2 over 3. And my x, if my y is 2, then my x is 0. On the x-axis, it's 0. And then my c stays c. So that is the equation for this. First, you need to figure out what the gradient is by working out from one corner to the other corner what was the vertical change and what was the horizontal change. Then you have your gradient. Then you can take any coordinates for y and x. I usually make sure that x will be 0. It's just easier. So where will x be 0? Where y is 2. So 2 is if y is 2, then x will be 0, and then c is just c. And that is basically all. Okay, so for the next one, they give us this equation. This is not a linear equation. As you can see, it does not meet the requirements for y equals mx plus c. There's no exponents in a linear equation. So if there's an exponent, you already automatically know it's not going to be linear. Okay, so for 3.2, also made some adjustments there. So use this equation y equals negative x to the power of 2 plus 1 to figure out what y is. So they give us x, we need to figure out what y is. So you can just write down the equation first, and then you substitute. So you're going to substitute x with minus 4. Remember, substitute in brackets. Okay, so negative 4 to the power of 2 is going to be positive 16. A negative and a negative makes a positive. 4 times 4 is 16. So to get this bracket away, you need to multiply the negative in. A negative and a positive stays negative. It stays negative 16. And that gives me with negative 15. Okay, so if x is minus 4, then y is negative 15. Okay, so you do this with all of these. If x is negative 2, then y will be what? Let's just figure it out. So that's negative 2 to the power of 2 gives me a positive 4. Multiply that with the negative, it's a negative 4 plus 1. That is negative 3. So that one's going to be negative 3. If x was 0, negative 0 stays as 0, and to the power of 2 that stays 0. 0 times 0 is 0, plus 1, so that would just leave me with 1. If x was 2, that would give me 4, negative 4. Oh my goodness. Yeah, okay. Yeah, okay, that's negative 4 plus 1. That's negative 3. And if it was a 4, that is negative 16 plus 1. That gives me negative 15. Okay. Okay, so now we've completed our table. Let's just go draw it on the Cartesian plane. So just quickly draw a y and an x-axis. So that's my x, that's my y. Okay, now you just need to plot the coordinates. So if x is minus 4, then y will be 15. Okay, so because we are working with large numbers, let's make each square in 2's, if you know what I mean. So instead of saying minus 1, we're going to say this is minus 2, and that's minus 4. And that would be 2 and 4 and so on. So you get my drift. So each square, we make it in 2's, just to conserve a little bit of the space that we have. We only have so much. So negative 4 would then be here on the x-axis, and then negative 15 on the y-axis would be down here somewhere. Minus 2, 4, 6, 18. So it'll be here somewhere. So let's just make a mental note of it there. And then negative 2 on the x and negative 3 on the y would be here. And then 0 and 1 would be there. Oh, sorry for my... Oh no, sorry, it's not there. It's here. And then 2, if it's 2, it will be negative 3, and if it's 4, it will be negative 15, so it's going to be down here as well. So I'm just going to take another color for you to see the line. So once you've plotted the coordinates, you need to join the dots with a line. Now we know this is a curved line, okay? So we're going to draw it as a curved line. Okay, so it won't be like a sharp end there, it will be a rounded end. Okay, just draw yours a little bit neater than mine, and you can also make an arrow to show that it will continue on, it can continue on. And that, if you've done that, then you've done with 3.2.2. So just make sure you have it. I'm going to erase it now, just so that I can see number 4. Okay, so number 4 says, the diagram below is a rhombus ABCD with diagonal BD. 4.1, why is the small lines drawn over AB, BC, CD, and AD? So that is the names of the lines. Okay, so why is this little lines drawn here? Okay, so the reason they do that is to show that those lines A, B, B, D, sorry, not BD, BC, CD, and AD are all the same length. Okay, so that's all you need to say there. It's because they are to show that they are the same length. 4.2, what is the size of angle B1, angle B2, and angle B3 together? So if you were to add them together, what will be the size of those three? And give a reason. So if you have a close look, I'm talking about those three angles. So if I add 1, 2, and 3 together, what will be their size? It will be 180 degrees. Okay? Because what do we know about straight lines? So you can see here, line AE is a straight line. And we know that angles on a straight line is always equal to 180 degrees. And that's your reason. So what's the size? It's 180 degrees. Why do we say this? Because angles on a straight line equals 180 degrees. 4.3, how many triangles do you see? Give them mathematical names. For example, triangle MNO. So if you look carefully, you'll only see 2 triangles. Okay? Their names should be triangle A, B, D. That's the first one. A, B, D. And the second triangle is B, C, D. Triangle B, C, D. We usually put these in in alphabetical order. So, but it's not. You won't be disqualified. But it's usually what is acceptable. You put the letters in alphabetical order. Okay. And then 4.4, what type of triangles are the triangles in 4.3? So if these sides are the same length, we're not sure about dB, okay? This one should not be, I don't think it's the same length because they didn't put a little line over it. Okay, so if the sides are the same, not all sides, but these two sides are the same length, then we call them an isosceles triangle. Sorry, incorrect spelling, isosceles. Okay, so these two triangles are isosceles triangles. If these two legs are the same size. Okay, let's go on to the next page. Okay, so page 4 and 5. 4.5, prove that ADB and ABD are equal. Okay, so prove that angle ADB, so if the angle is on the D, then we are talking about this angle, this one. Okay, so prove that angle ADB and ABD, so basically this angle, or I put in brackets angle B1. So So I need to prove that those two are the same size or equal. Okay, so very important to remember with isosceles triangles, okay, the angles that are opposite these lines, these equal lines. So basically, the angle opposite this line will be this angle, and the angle opposite this line will be that angle, are equal. So that's the thing with isosceles triangles. The thing we need to remember with those are that the angles that are opposite these lines are always equal, meaning they are the same size. I can just immediately say that because AD is equal to AB, okay, and that is given to us, by the way. If it's on the figure, then it's given to us, are the same size. So AD and AB are the same size, and because of this, angle ADB is equal to, I'm just going to say angle B1, because it is an isosceles triangle. Okay? And we know that with isosceles, the opposite angles of the same sides are equal. Okay? So you can just say because it's an isosceles triangle. So this is my reason for why I say this. Okay? That's all you need to do there. Let's go to the next one. 4.6. Prove that the triangles in 4.3, these two triangles, are congruent. Give reasons. Okay, so that's, now we just need to prove the congruency of these two triangles. So first thing we say is, in triangle ABD and triangle BCD, okay, and remember we need to as well give reasons for our answers. Remember with congruency you need to prove 3 givens, okay? So triangles have 6 givens. It's the 3 angles and the 3 sides that make up 6. But you only have to prove 3 of those 6. So immediately what I know, what they've given us, is that angle DC and DA is the same. So that's the first thing. And you also number it 1. Let's just do that, 1 and a dot. So I know that AD and DC are equal. Why? Because that's given. Okay. The second thing is the other 2 sides. Okay, so I can say that AB and BC are the same, and that's also given to us. And then the third thing, remember, I only have to prove 3 things. The third thing is that BD is the same as BD. Why? Because they are common sides. Remember, common sides are the same size. Okay. Therefore, I can say that triangle ABD is congruent to triangle BCD. And then my reason for this is to say what 3 things are the same in these 2 triangles. So we've proven it here. So this we proved was a side. This was also a side that we proved, and another side. So that's very easy. My reason will be side, 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 because I've proven 3 sides. So if you're not familiar with how to prove congruency, again, go back in your book and go have a look at that to help you. So do the exercises again. And that is all you need to do there. So if you've proven the congruency, you are done. And you need to end obviously with, therefore, triangle ABD is congruent to triangle BCD, and the reason is side, side, side. Okay. Question 5. Let's go to question 5. Determine the value of the unknown angles and give reasons. So here we have calculate the size of C and D. So angle C and D. There's D and there's C. So we need to prove, we need to calculate their size and also give reasons. Okay. Okay, so let's just first have a look at what we have here. We have a triangle, and we know that the sides of a triangle equal 180 degrees. Okay. But for me to get that, I need to get at least 2 of these angles to figure out what the third one is. Okay, so first thing I can see is have a look at this. These 2 angles. Remember, angles that are opposite each other, in this case, are equal. Okay, so if this one is 80 degrees, then D will be 80 as well. So I can say that D is 80 degrees. Why do I say that? Because opposite side, not sides, angles. You know what, I'm just going to make it easy for us. Angles are equal. Okay, so opposite angles are equal. Okay, so I figured out D. Now let's just figure out what C is. Okay, so in this case, where angle E is, there's 3 angles on a straight line. So remember, angles on a straight line also equal to 180 degrees. So we have 2 of these angles. We just need to figure out what E1 is. Okay, so the way I do this is I say E1 plus 23 plus 120 should equal 180 degrees. Why do I say this? Because they are angles on a straight line. Okay, please write it out fully. It's just easier for me to shorten it now, but when you do exams or tests, it's always safer to just write out the full words. Okay, so now I just need to, for me to figure out what E1 is, I just need to take over 23 and 120 and subtract it from 180. So 23 and 120 equals 143. So I'm just going to say 180 minus 143. And that should give me E1. So therefore E1 is 37. So I know that E1 is 37 degrees. So together, this whole angle, 37 plus 23, is 60. 60 degrees. Okay. So now I know that this is 60, this one is 80, and now it's easy for me to figure out what C will be. Just gonna make some space for me. So I know that C plus 80 plus 60 should give me 180 degrees. Why? Because the angles of a triangle equals 180 degrees. Okay. So again, do the same as what we did with the straight line. You just add these 2, which is 140. and then you take that 140 over and it becomes a subtraction. So therefore C is 40 degrees. Okay, so there you have it. D was 80 degrees and C 40 degrees. And once you've solved those two, you are done with the question. Okay, let's go on to the next one. So they say calculate the size, 5.2, calculate the size of E, F, and G. Okay, so first thing I notice is that these two sides are parallel to each other. Okay, so the angle of the arrows there mean that they are parallel. Okay, so we know that AB is parallel to CD. That will be one of our reasons as well. Okay, so let's see. Here we have opposite angles again, but we don't know what one of them are. So we first need to figure that out. Here I have angles on a straight line again. So it will be easy for me to just figure out what F is immediately. So let's start there. So F plus 30 plus 70 will equal 180. Why? Because it's angles on straight line. What you can also do is you can name the straight line. So we know that the straight line is CD. Okay, so angles on straight line CD. So those are equal to 180 again. Add these two, which gives me 100. And then you just take the 100 over and it becomes a subtraction. So that means that F equals 80 degrees. Okay, so we know that F is 80 degrees. Okay, that's the first one we've done. Only need to do E and G. Okay, so have a look at these angles as well. I know that F and E are alternate angles. So it's whenever there's parallel lines with a line through, then this one and this one will be alternate angles. And they are the same. So if F and E are alternate angles, then they will be equal. Okay? Alternate angles are equal. Okay? So that means that F is 80 degrees. Why do we say that? Because we calculated it there. So if F is 80 degrees, then therefore E is also 80 degrees. Okay. So F will also be 80 degrees. Okay, so now we've done that. We've figured out what F and E is. So we just need to figure out what G is. And remember at the very beginning I said that these are opposite angles. So they will also be the same. Why? Because they are opposite angles. Okay? So if E is 80 degrees, therefore G will also be 80 degrees. Opposite angles are equal, so I forgot to put that equal sign in there. And there you have it. We figured out what F was. F was 80. E was also 80 because F and E are alternate angles. And G was also 80 because E and G are opposite angles. Okay. Let's have a look at 5.3. Determine the value of H. So here we have a case of a straight line. And remember I said that straight lines the angles on a straight line are equal to 180. So all of these three angles should be 180. Okay. So if I say these angles together in maths means plus. So if I say 1 and 2 together, I mean 1 plus 2. So if I say h plus 3h together with h plus 30 together with 130 minus h, I physically mean adding them together. So I'm going to say h plus 3h plus, together means plus, h plus 30 plus 130 minus h gives me means equal to 180 degrees. And now we just simply, and your reason, I almost forgot about that, is angles on a straight line equal 180 degrees. Okay, so now it's simply just algebra, solving this in an algebraic way, meaning remember what we learned about algebra. You can add the h's and you can add the whole numbers. So let's do that before we take over. Simplify before you take over. Okay, so I can say h plus 3h plus h minus h. So that I can actually add and subtract. And that gives me h plus 3h is 4h, plus another h gives me 5h, minus an h gives me 4. Okay, so that all those gives me 4 h's. And I can also say 30 plus 130. That gives me 160. Okay, I can't simplify it anymore, so I'm going to start taking it over. If I take over the 160, it becomes a minus. (180 minus 160 is 20. Okay. Now I want to take over the 4. Remember, on this side it's a multiplication, so if you take it over, it becomes a divide. Okay, so therefore h is 20 divided by 4, 5. Okay, and there you solved h. And that's it. That's all you need to do there. Okay. Let's look at the very last one for this practice test. 5.4, determine the value of j and k. So here you have angles in a 360 degree rotation. But remember, a rotation, all the angles in a rotation will equal to 360. But look carefully. I'm working with a k and I'm working with a j. So it will be you can do it like that. You can say all of these angles will equal to 360. But it will be easier to do it another way. This is going to be more difficult because now you're working with two variables. Okay, so it's going to be hard to figure out two variables. It's easier just to go, okay, this angle and this angle are opposites, and this one and this one is also opposites. And what do we know about opposite angles? We know that they are equal to each other. So this one and this will be, this one and this angle and this angle will be the same. So let's start with these two. So there's actually going to be two calculations done here. One for this pair and one for that pair. Okay, so let's start with k. We're going to figure out k first. Okay? So 3k plus 66 that's the one angle, is the same or equal to 146 minus 5k. That's the other angle. Okay, so again, just simple algebraic equations. We need to just get k on the one side and alone. So for me to get k on the one side, I'm going to take over this 5k, okay, and remember on this side it's a negative, on this side it becomes a positive, okay, and I'm going to take 66 over, and you can do it in one step. I'm going to take 66 over, remember on this side it's a positive, so on this side it's going to be a negative, okay, and now I have my k on the one side and my whole numbers on the other side. So I can just simplify it. You see, I can simplify them before I do anything else. I can say 3k plus 5k is 8k. And I can say 146 minus 66 is 80. And now to get k alone, I'm going to take the 8 over. Remember on this side it's a multiplication. On the other side it becomes a division. Okay, now my k is alone, therefore k equals to 80 divided by 8, 10. Okay, so that's the one calculation. Then the next calculation will be for j. Okay, so for j, again, this angle and this angle will equal to each other. Okay, on the left side, I'm going to write minus 5j plus 38, that's the one angle. And on the right side, I'm going to say 6j minus 50. And that's the other angle. So again, I want to get all my j's on the left side and all my whole numbers on the right side. So I'm just going to take it over again like I did just now. So this is a plus on this side, so it's going to become a negative on this side. Minus 50 stays there first, and then I take over the 38, which will now become minus 38. And then I simplify, negative 5 minus 6 is negative 11j. Negative 50 minus 38 is negative 88. Okay. To get j alone, I'm going to take the negative 11 and divide. I'm just going to do it here. On this side, there's more space for me. So I'm going to divide negative 88 with negative 11. Okay, therefore, j equals a negative and a negative makes a positive. 88 divided by 11 is 8. So j is equal to 8. Okay, so we figure out what k is and we figure out what j is. And then you've done everything that you had to do. And that's it for this test. So if you can do this, you'll do very good in the real test. Okay. Have a nice day. Bye.